嗰個 pressure 啊，即係例如我哋舉例啦嚇，有個護土牆咁樣，咁啊實際去量度到個 pressure 出嚟咧，就係呢度咧就移動咗少少咧，佢量度到出嚟，即係總之佢量度得出嚟就係嗰個 K 嗰個數啦，嗰個 pressure 即係 horizontal pressure 就等於 vertical pressure。乘翻個 K， 即係佢量度都係咁啦嚇，即係都即係證明到啦咁樣。咁啊喐少少就得㗎啦，我哋留意佢下邊嗰個仲清晰啲啊，0.002啊，sorry，0.0005啊，喐0.005，即係如果我係 H 係1米嘅話咧，即係幾多？即係0.05 mm 或者0.5 mm，佢已經 mobilize 到啦嚇，已經達到呢個嚇。咁但係如果喺 passive 嗰度我量度咧，哦原來呢個窩要褪到好前咧，先至達到 KP 呢個數咁樣，即係呢幅圖就係解釋呢樣嘢嘅。咁啊要喐幾多咧？咁啊爭咗成好多倍啦呢個嚇。如果 H 係1 meter 嘅話咧，佢就係2個 mm 咯。如果佢係10 meter 嘅話咧，就係20 mm 咯嚇。你可以咁樣。呢幅圖就係咁用嘅。咁所以咧就變咗我哋 design 嘅時候咧，如果即係 in practice 咧就好正常地咧，我哋就如果係個 retaining wall active 咧，我哋就用 K 去計咯。咁啊個 KP 咧，即係我哋頂住佢嗰個力咧，就唔係好可信，唔係好可靠，即係靠佢嚟頂啊嘛，係咪？咁啊唔係好可靠，小心啲。咁啊 at least 有個心目中有個咁嘅 idea先。咁就如果係啦，有 query 嘅話，最理想就係去量度佢嚇，因為 doesn't mean 呢啲理論有陣時喺某啲情形度唔 apply 嘅。最 common 就係我哋如果嗰啲護土，即係嗰啲 sheet pile 係有個公子咁頂住嗰啲咧，就因為佢頂住噶嘛，有人唔喐啦，係咪？或者佢個 movement 係控制咗啦，咁所以其實呢啲就要諗清楚啦，用咩？咁啊當然啦 ，industry 有個方法做嘅嚇。我哋暫時唔講到嗰度先，我哋就係咁，即係呢幅圖就係咁用啦。我睇下各位同學都佢喺度啦，不就係咯。好，咁如果沒有讀有關 Geotechnical Engineering 那個前置科目，會唔會呢度前置科目就係嗰科 Engineering Geology and Soil 喎。冇就有問，即係你要問翻阿高君呢度喎。即係講到明 prerequisite 話你唔係好明你呢科係咩喎？我哋前置科唔係做 technical engineering 啊，我哋嗰個 prerequisite 係 engineering geology and soil mechanics 啊。你要 check 清楚啊！唔係好明你，因為我個即係因為個科唔係呢個科嚟喎嚇，唔係你呢個名啊。你睇翻個 upload 咗上去 Moodle 嘅 syllabus。Requisite 點算啊 ？Prerequisite yes。睇翻個咩就好啦，睇翻個。 silica 咁啊，當然啦，唔排除即係咯，係啦，如果就係呢個啦，要 check 翻你哋嗰個班主任。好，咁啊，繼續啦，有冇其他問題就？明白，OK。好，嗱，咁我哋繼續呢個 chapter 3，咁就係 retaining wall，咁就 share 咗呢個 OK， 好。咁主要分兩部分。其實主要就係 retaining wall 啦。retaining wall 咧就主要有兩個基本功啊，一個叫做 global factor of safety， 咁一個叫 partial factor of safety。主要係當然亦都有啲關於retaining wall 嘅計數啦。咁但係即係兩個。講完呢部分就我哋 tutorial one 上次都未講嘅，因為 tutorial one 都好 basic 啊，我哋講完呢個再講啦。OK， 好，錄咗佢先，開始錄啦。OK，start recording。你想點啊？畫面沒有改變。咦，沒有改變 share 咗啦咪？好，而家我 show 咗個 chapter 3，有冇問題？Cannot see 啊？哎呀，點解咧？It is still lecture 2。我 shift 咗佢啦噃，我 delete 咗佢咯，明咯。係喎，呢咁樣啦，即係 delete 咗佢咧。係喎，hang 機喎，好似。再 share 多次先。嗱，而家應該 share 咗chapter 3啦。停留在先前。好 OK，可能hang 機啊，可能啲 network 啊。OK， 好，咁我 start。OK， 我 start recording 啦，即係頭先我俾到錄埋啦。OK， so I'm going to start with the retaining wall design. So basically, I hope you get the idea that before we do the retaining wall design, we have to calculate the lateral earth pressure. So this is something that we introduced last time, lateral earth pressure. So in order to calculate the lateral earth pressure, we need to calculate the vertical earth pressure. So first of all, we have to calculate the vertical pressure, and then we have to calculate the effective stress, vertical effective stress. And then the next step then will be to multiply this by the Ka, assuming that this is active. And then after that, then we plot the pressure diagram. So we have a pressure diagram. So we use this pressure diagram and then apply this to the retaining wall. So this is the idea. And to prevent the retaining wall from failing, usually it's failed by either overturning or sliding. Okay. So we actually required the wall to be one of the methods to prevent it is by gravity, 即係用個重量 okay? So we are going to look at that one by one. Okay, so basically is to design earth retaining walls. So this is some interesting photographs taken before, because the trees itself sometimes may apply a loading to the retaining wall. So this is the typical retaining wall. In order to construct this platform, 即係做個地盤平整啦，我哋叫做英文叫 site formation 啦。咁啊變咗我哋要 construct 一啲咁嘅護土牆啦，呢個其中。Or we need some kind of retaining wall to protect this slope. So etc. etc. So this is the simplified explanation of typical retaining walls. So we have different kinds. The one that is most commonly used and quite simple is we call it a gravity wall. 即係靠重量砸實佢啦嚇。This is a typical one. And the other one, because it's quite expensive, the concrete, so we can actually use a L shape. So this is like an L shaped wall. And then we also, the weight, the soil itself can be used as the weight. So this will be compared with this one. This will use less concrete. So you expect this one to be more economical. So we call this cantilever wall. And sometimes we also use the pile to support a retaining wall. And sometimes we provide an anchor to provide additional support. So in this particular chapter, we will basically just look at this one and this one. And in chapter 4, we will actually look at this one and this one, okay? So again, this is actually taken out from a what we call a Geotechnical 1, the design of retaining wall. 咁我諗到而家啲同學都聽過 Geotechnical 呢個咁嘅啊，你打上網打 Geotechnical 1咁佢啊一陣間我都好似下邊都有 show 出嚟嘅，就會有紅書仔。So actually, these figures are actually taken from the Geotechnical. You can see this is a typical mass concrete wall. Of course, this can be in the other form or other shape, such as a trapezoidal shape, so that it is more economical. And of course, it can also be constructed using this method. Clip wall 即係咧呢啲係用啲石屎條砌出嚟嘅，咁啊可以即係類似一個預製件咁啦，咁啊中翻填翻啲石仔。So this is a typical one. This is called gabion wall. 用鐵絲網嚟做嘅，裏邊又放石，咁啊呢啲適合一啲可能呢啲淺嘅溪澗啊、河流啊嗰啲啦嚇。And we also have reinforced field retaining wall. 咁呢啲咧，when we design it, we will take this as a gravity wall. 即係成嚿嘅。And of course, for example, these are some of the examples. Must be thinking. So this is a clip wall. We also have this in Hong Kong. And this is the gabion wall. 即係啲鐵絲網 或者一個即係鐵籠咁嘅嘢啦，裏邊裝住石。咁啊呢啲咧就 reinforced earth，咁啊 with a panel in the front and there's some reinforcement and then backfill and then another layer of reinforcement and then backfill, etc. to build up this wall. So this is a typical names that we use to describe the wall. This is, as I said before, this is the cantilever wall, L shape or T shape or inverted T shape. 即係反轉嘅 T 啦嚇，反轉嘅 T。Sometimes we also need to provide a support to it, so we use the counterpart， 即係攞嘢撐住佢。Or in the front, it is called buttress. So these are, in general, these are called cantilever wall. Whereas for this type, it's actually also called cantilever, but this time it's called cantilever duct. So this is the term used. So this is the typical retaining wall when we design one. So it consists of very simple a stem. We call this a stem. 有冇呢個英文字啊？冇。Stem and then the slab. So this is a typical cantilever wall. Of course, sometimes we need to design the retaining wall with a shear key because it's a shear key. Again, this doesn't have that term. Shear key. 之後嚟找住啲泥嘅，找住啲泥。And behind this wall, usually, 唔係 usually 都一定要差唔多 provide some kind of drainage layer just to so when we I think last time when we start with the lateral earth pressure, we emphasize the importance of water. So we try to reduce the effect of water as much as possible. So by putting a layer of what we call drainage or filter layers or drainage material, you can actually improve the drainage.
阿瑞冇聲啦。 你瞄咗啊？
OK，sorry，係喎，OK，哇，哎呀，要咗好耐，哦，29，哦，啱啱先要嘅，而家得唔得啊？
講到第12
撳
版之後
咗個
俾佢咗。
掣喎，要可能撳咗個 Shift key。睇而家 OK 係，有陣時唔知撳咗個邊個係。OK，咁啊好快咁 go back 啦，咁呢都冇咩口水，即係 I think some of this you are aware of this, so this is a different type of earth supporting system. This one is quite new. This one here, so that it is constructed in a circular 即係圓形咁，佢受個壓力就會好啲啦嚇。So actually can save the use of horizontal support。又冇聲？哦，又冇聲嘅。啊，佢自己唔知點解會甩嘅。係OK，I hope you can see it now。好快啊！呢啲就係碌屎嗰啲唔同嘅 supporting system 啦，咁都係咁反而呢個想講下喎，點解咧？即係佢慳翻啲，你睇到佢 excavate 咗佢都冇喎，完全冇。咁另外一款咧就而家嗰個屯門嗰條隧道去機場嗰條隧道咧就佢嗰個 excavation 咧就用咗一個叫做花生殼嘅形式，即係其實佢都係啲 diaphragm wall 啦，即係 diaphragm wall就一橛一橛做嗰啲 panel 落去啦。咁變咗個 excavation 咧，你就好似呢啲咁咧，就減少咗好多啲呢啲 structure 即係橫搭，即係減少咗呢啲啊，減少咗呢啲，咁啊都幾 interesting，都聽到我哋啦，係唔知點解 OK，咁係啦，呢個條片都 interesting 嘅一啲辦法。Listen our anymore. EATEI ETEI 好，都細聲。咁啊，呢個我諗大家而家都好熟啦，呢個三角形啊，就係嗰個 soil pressure。當然啦，呢度就冇嗰個我哋所謂叫做 surcharge，不過如果有 surcharge 都係咁計嘅，冇乜得。咁你見到佢都有個 K 嘅。 咁啊，呢啲係我哋所謂叫 granular material 啊，即係逢係呢啲一粒圓，即係唔係圓啊，唔一定係圓啊，一粒嘅咧，咁啊 represent 一啲 granular 嘅。咁你見到咧，佢話 increase linearly with depth，咁呢個咁大家而家都明啦嚇。我聽到嗰個自己但我就主要係呢兩個see this two example, you can see that one of the retaining wall is L-shaped but facing outside, the other one is L-shaped but facing inside. So you see. So the video is asking you which one is better, whether it should face inside or whether it should face outside. Actually, each of this has its own advantage. Whether it's taking the alternate or taking the slide. So each of this has its own advantage. So this one may be better to take the overturning, but it's up. So it's about XCM. So how about the other one? The other one is a little bit better because it has the resistance of the overturning or sliding. Okay, so this is so you can watch this yourself at home. And okay, so we are going into the design. So we have, first of all, have to look at the failure modes. Basically, sliding, overturning, and bearing capacity. So these are the three things that we will look at. But for the bearing capacity, I don't know whether we should look at it today because we actually have a section on this. 即係我哋另外一個 chapter 專係講 bearing capacity 嘅，咁就會喺過咗 midterms 㗎啦。所以我哋 so basically we will look at these two first. But I will also introduce this, but there will be a lot more formula when we talk about this bearing capacity. So we will look at the sliding and overturning first. Okay, so so we talked about this different type of retaining wall already. So this is the 4 failure modes. So we'll look at the overturning. So if we have a force here, so we will actually cause the retaining wall to overturn. And at the same time, because of the horizontal pressure, so we can cause the retaining wall to slide. So these are the two things that we'll look at probably today. And then, of course, because this retaining wall is basically like a building, so it will also fail underneath. So if it fell underneath, then we call this a bearing capacity failure. Okay, and I'm going to D here. So this is a bearing capacity failure. If the failure is underneath the slab. Of course, because retaining wall is usually constructed along a, for example, some of it is used to support a slope. So this whole slope may fail as a whole. So this is another types of failure. But then again, because we have another chapter on slope failure, so for now, we will not look at this one for now, because this is like a slope failure problem. So we'll deal with this in the slope stability lecture. Same for this one, bearing capacity. Again, because this is basically the same as the bearing capacity problem, so we'll look at it in the bearing capacity chapters. So for these chapters, we will basically look at the overturning and sliding. Okay, so this is, as I said, if you type Geoguide 1, you will get this from the CEDD, 即係土木擴展處啊，土木工程及擴展處。So this is a publication. Actually, there are 2 editions. 兩個版本。Actually, both editions are valid. 即係冇話一個 edition 啫就 supersede 咗另外一個啊。Okay, so the reason why I point this out is that I don't know whether you remember when I mentioned that this chapter will mainly be divided into 2 parts. One part is that we use a term called global safety factor. And the other part, we use the partial safety factor. Okay, so 係咪都聽到㗎？而家應該冇問題啊。Okay. So we will look at this, and because both of this, the first edition actually described the global safety factors, whereas the second edition described the partial safety factors. And both of these methods are valid. 即係兩樣都可以用啊。So this is the, I don't know whether you have heard of this term. It is called authorized person. 即係中文就叫做認可人士啊。And it actually has a practice notes for the authorized person. So under this practice note for authorized person, then it actually point out that we can use both first edition, we can actually, or second edition in our design. So this is authorized person practice notes APP-63. 咁喺呢個認可人士作業備考嗰度咧，佢都 point out 啦。咁啊有兩個唔同方法，咁啊你話兩個方法都得㗎嚇，所以兩樣方法都會講，因為出邊啲 design 都兩個方法都會有用。OK， 但係記住咧就你入職嗰陣時就 make sure 咧就係用邊個方法啦。同埋你唔可以溝啦 ，cannot have a mixture， 即係唔可以一啲就用 first edition， 一啲就即係一啲用 global factor， 一啲就 partial factor 又唔得咯。So this is the idea. So we will talk about both methods. Okay. So basically, we'll look at the failure, ultimate limit state, but of course, there's also other things that you need to check, such as the other performance that the retaining wall cannot meet, such as settlement, etc. And again, we have another chapters for checking settlement. So for checking settlements, we'll based on that chapters. Okay, 咁咧就 we'll check basically sliding and overturning. 咁我哋咧個 bearing pressure 咧，我哋就會 check 一個 assume 已經俾咗你㗎啦，係啊，即係喺呢個 chapter 裏邊。咁啊要 check 嗰個 bearing pressure 達唔達到要求。Okay, so we'll talk about this one by one. How to check overturning, how to check sliding, how to check the bearing pressure if the bearing pressure is given. Okay. 好，咁我哋都會講個 partial safety factor 嘅，咁好，咁呢個開始啦。So assuming that this is the retaining wall, so by now, first of all, we have to calculate we have to plot the pressure diagram, right? We have to plot the pressure diagram, and then we have to find this force. And sometimes you also need to find this the line of action， 即係嗰個中心點，呢個 force 嘅中心點嚇，因為我哋 take moment 啊嘛嚇，就有個 force time distance 先可以 take 到 moment。So before we do anything, then we have to calculate this lateral pressure based on what we have learned from chapter 2. Okay, so let's say here if we have a retaining wall like this, then we will then calculate the checking. We'll then check the sliding. So for sliding, I think you have to check the factor of safety against sliding. So it's the force that causes to the total horizontal force divided by the total resisting force. So the total horizontal force then we can calculate based on this, assuming that we can plot the pressure diagram, so we can calculate the force. And then if we have a passive resistance, 即係有個床咗落地下 so this will actually give the passive resistance. So we can actually take the net， 即係揾個 net 嘅意思，即係個即係 active 減翻呢個啦嚇，減翻呢個，咁就係 total force horizontal driving force。咁個 resisting force 咧就係個 friction。resisting force 就係呢個 friction 加埋呢個 force 啊。咁個 driving force 咧就係呢個 driving force 就係呢個嚇，得唔得啊？個基本 concept 就係咁咯。driving force 就係呢個。個 resisting force 咧就係個 friction。其實靠 friction 主要都係，咁如果有呢個咧就加埋佢啦，所以咁之前講過啦，咁有啲人用，有啲人唔用啦嚇，即係因為之前講過啦，個 passive resistance 咧就未必信得過，係咪啊？咁甚至乎咧信唔過嘅話咧就之前都講過啦，亦都唔排除咧有陣時我哋掘路咧，咁冇咗呢個 passive resistance， 咁有個風險喺度啦，計佢嗰時，咁呢個咁由個 engine 去決定啦嚇。好，咁基本上係咁啦。咁如果有 shear T 嘅話咧，咁要計埋個 shear T 嚇，所以即係話咧就我哋咧就要去到落到底嗰度啦嚇。 嗱咁點解要 shear key 咧？因為你睇到咧呢度係石屎啊。This is actually concrete, and this is soil. And the friction between the concrete and the soil is actually less than the friction between the soil. 即係泥同泥嘅 friction 咧就大過，因為石屎都有個面㗎嘛，係咪？即係石屎同泥嗰個 friction 就細過泥同泥嘅 friction。所以如果係個 sliding 唔夠咧，我哋又可以做個 shear key，咁我哋找實啲泥，咁呢個 friction 就大啲啦。OK， 咁overturning 啦，咁overturning 我哋就我哋唔好理，即係係咪斜個 slope 啦，斜 slope 都係咁做啦。咁我哋都係 plot 翻嗰個pressure diagram， 跟住又數翻 out the horizontal force and then take moment about this point. You can see take moment about this point. And then the force to resist it, that will be the weight. 即係記唔記得 the type of retaining wall we call this is gravity retaining wall. 記唔記得啊？ So because it's called gravity retaining wall, so it actually has a weight. So this pressure will actually overturn this, but then the weight of the wall will actually resist it. So this will resist it, whereas the wall will overturn it. So this soil will provide a overturning moment, and the weight of the concrete and the soil will provide a resisting moment. Okay, so this is the idea. So this is basically to add all those moments together, and then in Hong Kong, when we talk about the global factor of safety, the factor of safety is actually greater than 2, and it's actually 3. So we'll look at that later. And then the last thing we also need to do is to check the bearing capacity. 咁我哋 check 呢個 bearing capacity， 因為我哋未教啦嗰個泥土嗰個可承受力。咁我哋喺呢度咧就 assume 嗰個可承受嘅力就 given。咁你睇到咧 ，you can see that if it is just a normal bearing, normal foundation, the pressure here will be uniform, right? But because we have a horizontal force to overturn this, so you expect the pressure over this side will be greater than the one on this side. So it is necessary to calculate this pressure, and then to make sure that this is less than the allowable pressure. Okay, so this part we have to do it. 即係 check 翻揾翻個 maximum 嘅 pressure。咁喺呢度 assume 呢個數咧就given 住先啦嚇。我哋遲啲有另外一個 chapter 就教點樣計呢個啦。So there are 3 things we need to check. One is the sliding, one is the overturning, and the third one is the checking the bearing capacity against the maximum pressure. And there's also a concept called eccentricity, because if the overturning is too much, that means the pressure here is very high, whereas the pressure here is very small. And if the overturning pressure is much higher, what that means is that the pressure here is very high, and the pressure here may at one point become negative. become negative, this is something that we don't want. So make sure that there's no negative pressure here. If we don't want any negative pressure here, then we have to check this eccentricity. Make sure that this is less than 1/6 of the width of the foundation, but we'll talk more about this later. So basically, again, I repeat, we have to check sliding, check overturning, check the maximum pressure, and also check the eccentricity. So these are the 4 things that at this point we have to check. Of course, there are more other things to check, but for example, the slope, you still have to check it, but then those are included in another chapter. This is another example how to calculate the allowable bearing capacity of the soil. But we will introduce this in another chapter. 咁我哋呢個 chapter 就唔包呢個啊，但係我哋就會 check maximum 呢個，同埋 check 個 eccentricity。Okay, so far is there any question? 好彩就冇跳啊，今次 OK。Okay, any question? So if there's no questions, I want to continue. Maybe we'll look at the tutorial 1 very quickly. Tutorial 1 is how to calculate the Tutorial 1. Okay. 因為 Tutorial 1就溫一溫書咁樣嚇。Tutorial 1。好彩有 open with. Okay, hope. So this is tutorial 1, and quite straightforward, I hope. And this is the answer of the tutorial 1. So, okay. Open with. Okay, hope. So I think you can see this. This is the tutorial 1. You can open it with Excel, but so this is the different layers. So you are asked actually just to calculate the lateral earth pressure, just to plot the graph. I think this is. So you have different layers in here. And also calculate the water pressure on both sides. So you assume that somehow there's a ship out or whatever, and you have a pressure here. Somehow you calculate the pressure, and somehow you also calculate the water pressure. This is something like that. So you have the active pressure, I think. Oh, so you are asked to calculate the active pressure. and also the passive pressure. And also calculate the water pressure on both sides. So we are asked to calculate both. So by now you should aware that if you substitute Ka, 1 minus psi phi over 1 plus psi phi, etc. And then you have Kp, 1 plus psi phi over 1 minus psi phi. So let's say if this friction angle is 30, then you will find that Ka is about 0.33. So this is 30, Kp is about 3. Kp 大過 K 好多嘅，因為佢俾人谷住啊嘛，係嘛？ I think by now you should aware of this. 即係有個 idea 嗰個數個大細啦嚇。Okay, anyway. Okay, so we look at the there's a table as well. So first of all, then you have to calculate this. So you have to calculate the Ka and Kp. So this is quite straightforward. So you have the so you have the friction angle given. So you have all the friction angle given. So you are able to calculate Ka and also Kp. So this is your first step to do it. And then the second step is that the calculate the vertical pressure. So you have different layers, and then so you have the density times the density unit weight. By now, I think you should get used to this unit. 呢個我哋就係所謂嘅 unit weight. So the unit weight is actually called unit weight. So the unit is kilonewton per meter cube. 咁啊，即係慳翻唔使乘9.81除1000咁解嘅嚇。So times h. So you obtained the vertical stress and then multiply this with Ka minus 有個 cohesion 喎嚇，成條 formula 記住。If you still remember, actually the whole equation is the vertical stress times Ka minus 2c root Ka. Okay, so in this case, the cohesion is 0 for the first layer. Okay, so that's why you get the first point. 咁如果我哋要 plot 咧，就係第一點就係0啦嚇。So at the ground surface, then the pressure is 0. 咁啊，第二點 if you want to plot the horizontal stress, the second point is 17.514. And then we are asked to find the next layer. So next layer 就加上去啦。So this add here. And then because this is underwater, so we use the unit weight. 因為佢浮喺水啊，記住呢度。If you still remember, this is water is here. So underneath here, then the unit weight will be minus this to calculate the effective stress, and then multiply that with Ka. Okay, so this is right here. Of course, at the end, the horizontal force, the water will also provide a horizontal force. That's why at the end, ask you to calculate also the water pressure. Okay, so the next step then will be to calculate the pressure at this point, vertical pressure at this point, and then again multiply it with Ka. Remember to include the cohesion, but this time it is 0, so nothing to worry about. And then this point, again, remember this layer has a Ka equal to 0.307. And this layer has a Ka of 0.422. 即係呢點咧有兩個唔同 Ka 喎。So for this part, we have to use 0.307 to calculate the pressure. And for this part, for the same 即係呢個 same 深度咧，呢個 Ka 就轉咗嘅喎嚇。So we have to calculate this twice， 計兩次喎，用唔同嘅 Ka 喎。呢個就係用咗0.307，呢個就係用咗0.422。So actually there are 2 points here. One point is 28.8, the other point is 36.9. 36. So 即係呢一點咧就記住咧，佢有兩個點喎，打橫。得㗎，我後邊唔知有冇？我有 plot 出嚟喎。不過 Excel 唔知有冇 plot 到咧，我都唔記得。嗱咁第一點就呢個啦，跟住呢度咧，因為唔同，我哋有 different layers 啊嘛，right？ 我哋 it actually have 3 layers. So at the interface, then we have, because of different Ka, so we have to calculate this twice. Same for here. We have to calculate this twice. Okay. So I actually just plot the active pressure, so you can plot the passive pressure yourself, but the idea is the same. The reason why I want to discuss with you is mainly because of this point， 即係因為呢個有好多同學可能有機會搞錯咗、計漏咗咧，所以我專登就喺度提一提嘅，其實最主要嘅原因。Same for the rest is the same 啦。So actually the rest is the same. Make sure again we calculate this twice because of the change in Ka. 咁有嚟到呢度有呢度唔係呢度一條直線，呢度一條直線，咁打橫，一落到嚟呢度咧又好似縮翻咁啊 ，something like this. So if you plot this, so you will get something like this. Okay, so this is your, after you calculate all this, then this will be your active pressure. So this will be your active pressure. Then you are asked also to plot the water pressure. So if you want to calculate the force, then it will be this area plus this area to give you the total horizontal force. And then after you calculate the lateral pressure, then passive pressure 都係咁計啦嚇。咁我唔再 repeat 啦。咁當你有一樣就咁水應該一樣噶啦，水一模一樣噶啦，左右。This will be the same, but the active pressure and the passive pressure will be different. So you can try this at home, and if you want to plot this out, So you have to get yourself familiar with how to, first of all, calculate Ka, Kb, and also how to calculate the vertical stress and then the horizontal stress, and then plot the diagram. And then for the passive side, basically it's the same, but the formula will be different. So it's the vertical times Kp, of course, and that is, instead of minus, then you have plus 2c Kb. So that's the difference. So for the active pressure, so you have this. For the passive pressure, then you have this, right? So you just do the same. 得，即係要有咁嘅準備先得嘛。So you have to prepare. So you have to make sure you prepare yourself to. Usually, you can use it with a table, and then it may help you in your calculation, just like this. 得唔得啊？OK 嗬。嗱，咁有樣嘢我想提一提，唔係呢個。即係如果你啲泥土係咁啦嚇，我拆咗呢啲先。So if you have layers of soils like this, and if you are, let's say you have a slope, and you have layers of soils like this, and then you are asked to construct a retaining wall. So you are asked to construct a retaining wall to retain this soil. So after the soil has been retained, then you can actually excavate away the soil, right? So usually this is the existing ground, and then you are asked to construct a retaining wall, something like that, and then you can excavate the soil away, and then you can construct your building here or whatever, right? This is usually what we do. So in constructing this wall, what did we do? 即係呢度，我哋可唔可以插嚿石屎落去啊？ Of course, we cannot insert this level. So what we got? We actually need to excavate this soil as well, and then we need to backfill this soil, right? 即係掘走咗佢，釘板紮鐵落石屎，然之後就咁呢度吉咗佢，空咗喎，咁我要回翻啲泥係咪 ？So if we backfill the retaining wall, we usually backfill it with a suitable material, usually granular material. So sometimes you will see that the backfill materials will be different from those of the native material. 即係同佢原生嗰啲泥又唔同嘅。咁理論上你應該用翻 backfill 嗰啲泥去 design 啊。Whether it's the weight or whether it's the friction angle, etc., etc. Okay, so we'll talk more about that. Okay, so far this is tutorial 1. Tutorial 2、3都可能會開始講一講，咁啊。或者我放一個 tutorial 2嘅先。 原來我呢度OK，呀，OK，show OK，before 3都 show。OK，好，咁睇下有冇問題啦。So before we go further, that I hope you have a basic understanding how to plot that pressure diagram and how to use that pressure diagram to do the calculation. 好，咁睇下有冇問題。呢度就收咗佢啦，呢個冇乜特別。呢個都呢邊，呢個都有得佢先。好，咁睇下有冇塞咗個聲冇啊？有陣時唔知撳咗邊個掣。咁有啲同學仲未上 Moodle 嘅喎，我就 send 咗。有啲同學係未曾。先，好，點乜點名先？Meeting guest 入唔入到嚟呢個？林卓峰。有啲同學都冇返。沙沙。好，咁if there's no questions, then perhaps I will continue 啦。咁after I continue with this example, then we will take a look 講埋呢個先。Okay, so this is an example. A retaining wall, a cantilever type of retaining wall. So the shear strength of the soil is cohesion is 0 and the friction angle is 36 and the unit weight. And this one is simple, and because the water table is below, so there's no water to worry about in this case. And we'll also take the friction angle between the concrete and the soil to be 27. And we also need to know the unit weight of the concrete. And then we will check basically sliding. 應該 check 晒4樣嘢喎，睇下唔知我唔記啦，係啦 ，check 晒4樣嘢。當然咧，有啲就純粹 sliding 啦，overturning 啦，仲有一個 maximum 嘅 bearing pressure 啦，同埋嗰個 eccentricity。So these are the 4 things that we will check, and we will check it according to the global safety factor. 咁global safety factor 咧就相對上就容易理解啲嘅，我都係呢度講埋㗎啦。global safety factor 即係一個 safety factor. What it means is that, for example, we have a safety factor and then we have overturning, overturning. So we have to add all the moments, resisting. All the resisting moment divided by the overturning moment. So we got the factor of safety. Okay, so this is what we call a global safety factor. Okay, but however, in your structural analysis, if you still have structural design, you actually have a different factor of safety. If you still remember, one is 1.4 dead load 係咪？好熟啊呢啲 1.6 live load, right? You are very familiar with this, right? And you are also familiar with the factor of safety used for concrete and steel. So if you have a factor of safety for the yield stress of steel, so you apply a factor of safety to it. I don't remember exactly what is the factor of safety you apply to your steel. I think it's 1.18. I don't know, actually. Let's say it's 1.18. So you can see here that actually there are two factors of safety. One factor of safety is used for the loading, and the other one is used for the material, right? So they actually are using a partial factor of safety. So this is another design philosophy, okay? And of course, in this case, we use the global safety factor, meaning that we only use one safety factor. And in examples later on, we will use the partial safety factor to check again, okay? So, but for now, we will look at this one first. Okay? Okay, so as I said before, the factor of safety in Hong Kong, we use the Geotechnical 1 first edition 嚇，記住啊。咁你去 second edition 揾唔翻呢個 table。So the first edition, so this is the factor of safety. Sliding is 1. I think this is 5. Overturning is 2. Bearing capacity is 3. So these are the factor of safety to be used for new walls. And for checking of existing wall, we can use this. 即係你喐過個 retaining wall 都當新㗎啦，除非你係 remedial 啦，或者 check 佢嗰個 existing 啦嚇。OK， 好咁in this case we have a surcharge. So you can learn how to solve the problem with surcharge by looking at this example. Surcharge 都冇乜特別嘅，其實 surcharge 都係 based on the table 啦。So you still remember, if there's no surcharge, this start with 0. But then if there's a surcharge, then it starts with 10. Okay, so 呢個咧就睇下你中意點啦。Let's see. 哦，呢個加十呢個係喎，呢度呢個係加十，加十就101係啊。呢個係101.8喎，呢個 OK 嚇。哦，咁後轉頭改翻佢先，呢個 OK 啊。Okay, so we start with a surcharge of 10. So first of all, of course, because I think the friction angle is the friction angle is 36. So I assume you substitute 36, then you will obtain the 0.2526. Okay, so you start with 10 because we want to plot this pressure diagram. So 10 vertical stress is 10, so multiplied by Ka. So the first point here is 2.6, and then the second point is 10 plus 5.4 times 17 is 101.8. 哦，呢個係 delta 嚟嘅，咁啊，所以都啱嘅，咁樣寫法都啱。因為呢個先係 vertical stress 嘅，咁啊呢個即係呢個加呢個就等於呢個。睇下你個 table 中意點啫。Okay, so this is the 101.8. Sorry, the times Ka. Now becomes 26.5. 因為呢個係 delta sigma 喎，咁啊，所以呢個都啱。不過記住咧，就係當你計 stress 嘅時候咧，就呢個加上，即係要加埋佢，加埋晒佢先至係個 stress。Okay, so this is how you obtain this pressure diagram. So even though you have a what we call a surcharge rail, so it is quite strict. It's the same the way that you calculate. So you have this pressure diagram. Then the next step, then you can use this table and to calculate the horizontal force. So this is 2.6. This is 26.5. So the area actually is the total horizontal force. So the height is 5.4. 即係個高度5.4. So it's very straightforward. Times, so this area is 14. 咁啊呢個三角形啦，三角形。咁由呢度至呢度26.5喎，所以要減翻呢個啲咁多。但 5.4 咁啊一個三角形啦。So it's 64.5. So this is your horizontal force. So when you are checking sliding, then you should use this to check your sliding. The next step is to calculate the overturning. So overturning 咧就係就係佢嘅中心點咯。So we usually use either a 即係個梯形嗰個中心點，我又唔係好識計啊。咁所以咧，我通常拆開佢長方形還長方形咁啊，三角形還三角形。So this is how it is done. So this is a rectangular shape. So we have the force is the moment arm. If you take moment above this point, and it is 0.5 times that, and for a triangular shape, then it's 1/3. 咁呢個要識啦嚇 ，triangular shape and one-third 嗰個中心點。So this one times this one, then will give you the moment. So this is the overturning moment. And then this is the overturning moment. This is the sliding force. So when we are checking the factor of safety of sliding and checking the factor of safety of the of overturning, then these two will become the 分母啊，係啦。Okay, so what is the resisting force? The resisting force then will be the weight. 咁啊 weight 就係好似係咁樣啊，咁啊將佢切咗幾嚿啊，咁啊啲咁多三角形嗰啲我哋唔計啦，啲咁多，咁就應該就三嚿啦。So this is the stem, and this is the base, and this is the soil. So this is the vertical mass or the weight of the concrete and the soil, and then it added up, then becomes the vertical load. 咁 vertical load 再成個 friction 咧，就係個又要大過呢個咯，咁啊好簡單。Okay, resisting moments again. We have to calculate the center. 咁啊呢個你自己諗辦法計翻嗰個由 center 計落嚟啦。呢個0.95突出嚟。0.3係0.95。咁我呢個唔好理佢啦，呢個三角形細細地啊。咁呢啲大家識得做啦，計翻個石屎，記住用翻石屎重量，呢個用翻泥嘅重量。Okay, so we take moment about this point. So all this will, these are the moment arm of each of that, and then again this time that will then becomes your resisting moment. Okay, and then after you calculate this is very straightforward. Then the factor of safety then is equal to this divided by that. This is the resisting moment. This is the overturning moment. And then the factor of safety against sliding then will be the resisting friction divided by the horizontal force. So this is very straightforward. Tôi喺上邊咁樣，咁啊呢個都係啦。咁啊 friction 記住係27喎。So this is bigger than 2. This is smaller than 1.5 喎。咁唔得。但係呢個 example 係書嘅 example 嚟嘅嚇，咁啊就唔係 based on Hong Kong Code 嘅，記住。嗰本 Clay 嗰本書嘅應該。Okay, so this is done. Checking, overturning, finding the factor of safety against overturning, and finding the factor of safety against sliding. So this is done. And then the next step then will be calculate the eccentricity. Because we are taking moment about this point. 咁啊，我哋嘅 eccentricity 係中間3除2開始計啊。So eccentricity then will become the again 個 net moment divided by 個 vertical load。咁因為我哋由呢度度起喎嚇，所以So the lateral arm then will become the net moment divided by the vertical load. So the net moment we calculated here. Net moment divided by the vertical load to give the eccentricity along the vertical. 即係我哋咁我哋呢個 net moment divided by 呢個 vertical load sorry 呢度畫得唔好 ，vertical load 係理論上係由中間度起啦。咁我哋係由中間度起，咁我計到個 eccentricity 係幾多？ So make sure that this eccentricity is less than b over 6. So if the eccentricity is exactly equal to b over 6嘅話咧，咁佢應該個 pressure 就會咁啦，C。咁如果佢細過佢咧，就會有咁嘅如果佢大過佢咧，就有咁嘅現象啦。咁有個 negative， 得唔得？呢個就係個 concept 啦。咁點解係 B over 6咧？咁同你哋嗰個唔知有冇學過啦，個 short column 嗰個 concept short column， 即係我哋有 vertical load， 亦都有個 moment。咁我哋個 vertical load 咧就係個 pressure 咧就等於翻個 total load vertical load 除翻個 B。當然咧，我哋就有個 L 嘅，即係 area。咁但係個 L 我哋當1啦嚇，因為好長啊嘛，我哋經呢個學嘅，係嘛？即係理論上就個 vertical load divided by 個 B 就係個 pressure。咁當然啦，我哋仲有個 area 就係嗰個深度啊。Anyway， 但係個 moment 未計喎，咁加減個 moment。咁個 moment 咧就係等於 vertical load 成個 eccentricity 嘅個 moment。成個 moment。咁除咩咧？我哋 moment 喎，記得你哋好熟嘅一條 equation 啊。記唔記得你哋有條咁嘅 equation moment stress 等於 moment over 或者等於 moment y 除 I 唔記得晒啦。But anyway， 咁咧呢個 Z 咧就係呢個嘅意思啦。咁就係 B 乘呢個除12。咁變咗咧就係除 B square 除6，即係我哋一個 rectangular 個 I 啊嘛 ，phi 就係 B 3除12，你2Z嘅話咧就 B square 除6咁樣咯，係啦，就係咁嚟咯嚇。 咁所以咧點解要有個6就係咁解啦嚇。你代翻呢個入去咧就係出咗呢條啦。加減嘅意思咧，因為可以咁咬，可以調翻轉頭咬，所以咧就咁咬嘅時候咧，呢度就係 maximum 啦嚇。咁但係呢度咧就會變咗負數啦，所以咧就加減嘅 maximum and minimum. So this is how this is developed. Basically, based on just basic structural mechanics. Okay, so based on this, then you can calculate the maximum load, maximum pressure, and also the minimum pressure. And make sure that the maximum pressure is less than the allowable. Okay, make sure, for example, this is less than allowable. And if the eccentricity is less than B/6, then this values is always positive. 但係如果呢個細個 B/6咧 this become negative， 咁就唔係好 recommend 啦。Okay, so this is the basic checking of a retaining wall to check the overturning, sliding, and also the eccentricity, and also to calculate the maximum bearing pressure using the global safety factor. 哎呀，OK， 我見到有啲 message 我係又冇聲嘅。Not share， 哦 share 咗啦。Okay, maybe a break for 2 or 3 minutes, then we'll come back to talk about the partial safety factor. 咁長遠嚟講咧，都會